this session for people who are interested. I have started the recording. Before we start, a couple of logistical items. As I mentioned, the session is being recorded as we speak. We would appreciate if you could turn off your microphone for now. There will be a moment in this webinar where we ask you to open up your microphone. We will also use Slido for some interaction and questions. These questions are quite short. We will keep them open for about 30 seconds, 45 seconds for you to respond. We may not wait for everybody to respond because we may have quite a few people joining. We're over 20 already. If you have any questions, feel free to place them in the chat. So we will get back to these questions. And also towards the end, there will be time for some questions as well and some interaction. So that's the logistical part. As far as the topics and the content, these are the topics for today. Jan Kees will start with a short intro, who we are. Then he will talk about the maturity levels, about data models and knowledge models. And we can look at some use cases. We have several use cases, probably too many to cover in this whole webinar, but at least we're going to show some of them. And then we'll end with make, buy, or co-create. So this webinar is presented by Jan Kees Schakel, the founder of Sensing Clues. So Jan Kees, over to you.
Thank you very much. Welcome, everyone. Nice to see many faces that I know, but also many faces I have never seen before. Hope this is a start of a wonderful journey together. I'm Jan Kees. We are Sensing Clues as an organization, and we represent and actually coordinate the Nature First program. You see that we are with 12 organizations across Europe working on solutions to monitor biodiversity. And this afternoon, we're going to highlight a few examples, very practical operational examples that hopefully will inspire you on what you can do with data and how you can make use of all the data opportunities that are out there that not everyone is yet making use of. Next slide, please. So that was one too much. So the Nature First program actually is a 3-year program funded by the European Commission and aimed at innovating the biodiversity monitoring processes. We are using remote sensing technologies, not only from satellites, but also from sensors like camera traps and maybe sounds. We are using forensic intelligence, and we are using what we call digital twins, which in this presentation also will be presented as radars, like a weather forecast radar predicting in real time what's going to happen next. So we are looking at continuous monitoring, not every few years, as is often the case currently. When you look at Natura 2000 areas, then often there's no money to constantly monitor them, so it's only done sometimes even only once in every 7 years. And we want to be able to do that constantly. Real time for us is the benchmark, and that information then can help you to inform your activities and your action, which then can become more proactive if you are able to act in time. Everything that we do and that I'm going to show is tested in the field. So it's in terms of maturity level quite high. Some of the things are really TRL 9, which means it's foolproof. Many others are being tested and have been roughly tested in the field and are waiting for next projects. We do this monitoring across different data sources, quite a lot of examples in the presentation. Also taxonomies, like you've got taxonomies, as you know, from the biologists, where you have all kinds of species audits, where the birds are among the birds and the mammals and so on. But as you all know, taxonomies are not always straightforward. We do it across boundaries of areas and also across boundaries of languages. Next slide, please. The part of doing more with data is, of course, organizing your data well. So our premise is that whatever type of data we are looking at, it can and should be integrated and harmonized. And for this, we use ontologies, taxonomies, and thesauruses, which I will explain a bit more later. But that is actually then turned into information internally and also mapped with open data sources externally that are ready for use. And then when we talk about usage, then we talk about how can you use that information to monitor nature conservation areas and everything that happens there, how to make risk assessments, where are things might go wrong, where you should pay attention, real-time risks, which allow you to immediately act, and scenarios. So that's the top of the bill. If you can project a few scenarios and see what might happen. So it's more for policy making. Next slide, please. So before we dive into the technologies and the data questions and so on, we have a few questions because I'd like to know whom I'm presenting and working with, because I'm going to try to tailor my questions and examples to who you are. So if you can please use your phone and look at this QR code and answer these questions that follow. And in some cases, you can give one answer. In some cases, you can give multiple answers, like ranking. So please show us who you are. So we've got at least 2 researchers in the room. A data scientist is coming in.
You can also use a web browser and go to slido.com and then enter the room number 1517684 if the QR code is not working. You can also use a browser screen to participate.
There's people that analyze a lot of data. There's people who are responsible for teams. And when we talk about teams and leading teams here, then we look at data-driven organizing, data-driven decision-making, or fact-based decision-making as an alternative. It's good to see. We also have domain experts, very well. So, and we don't have any application developers here, so that's also good to know. Because one of the things that we actually aim for also as a program, but also as Sense Includes, is that we see a lot of researchers and a lot of analysts and a lot of domain experts and even data scientists who create wonderful analytics and wonderful algorithms and solutions, but who struggle with making these solutions available for a wider audience. And if we want to make impacts in nature conservation and want to enable organizations in the field who often do not have that lot of technical expertise in-house to work with our solutions, then you also need a few application programmers and developers. So that's what we try to accommodate, which I will also show you later a little bit about. With an interesting audience. Thanks. Next question. What would you like to learn today? We give you 30, 40 seconds to answer this question.
And this is going to be a word cloud, so you have a limited number of characters. So try to use sort of a keyword, something you would like to learn today, please.
I don't know who wrote data middle, but maybe can you explain it in the cloud, in the chat function? I'm not sure what that means.
Maybe data model?
Model, probably. Yeah, data modeling. Yeah. Integration of data, an important team indeed. Coaching ID. All right, very good. Thank you very much. We'll continue to the next. So in your practice, when you are working with data and when you're trying to think about your work, what if you think about data are your biggest frustrations? Could be anything. It's also a word cloud. So. Very good. Yeah, thank you. So I will dedicate quite some time also on the harmonization and integration of data modeling and how to create data models. So that's good to see. Yeah, and I hope it will not be too overcomplicated. It needs to be practical. Yeah. Thank you very much.
Still 2 participants typing. So let's wait one more second. Fragmentation, storage. Okay. Yep. Yeah. All right. So let's continue.
So again, there's a little assessment on how data-driven are you. So we know a little bit about who you are, about the frustrations you are having. And before we go a bit deeper, the question is also, what kind of data-driven aspects are you already familiar with and which ones not? Next slide, please. So I'm asking a bear here. So when you work with data, then what in your perspective, from your opinion, is the thing that you work mostly with? And this is a ranking, so you can rank them in accordance with what you like, and if you do not use them, just don't touch them.
You can select multiple and then rank them according to your importance or importance to you. If all are applicable, you can select all, rank them in order of importance for you.
It's quite a lot of researchers around the table here, so I would expect indeed many people involved in modeling, development of algorithms. Of course, it all centers around data, not so much in knowledge rules. I know 1 or 2 guys around here who do use knowledge rules, like Boris in VA data. Okay, very good. So a lot of people are working directly with the data. Quite a lot of also use it for modeling. Some pipelines, some processing, some routine type of processing of the data to put it in a shape that you like. Algorithm development and detection of knowledge rules. Okay, thanks. Next. The other question is, what kind of data are you working with in terms of ownership? Is it your own data? Is it the data that you or your organization produces? Is it information that you buy or get from third parties? Or are you also familiar with LOD? And I'm not going to explain what that means, but because if you don't know the abbreviation, then you probably don't use it. And I will explain it later, what it is. So a lot of people are working on their own data, a bit less on the data of third parties, and not so many yet with the LOD. It's an interesting one because one of the things that I will explain later is that we were talking about the availability of data, and often people look in their own database to see if they've got the data, but not so often whether the data is not already out there somewhere on the internet with a third party or in a linked open data repository, which is LOD. All right, thanks. Next. So then if you look at the types of information, of course, those are data sources, where do you get your data from? Then what type of information do you actually work with? Is it observation reports from people in the field? They see a bird, they record a bird, they find a snare, they record a snare. Is it measurements, like sensors that you use in the field to measure the temperature or the water levels in the river? Surveys to question people about, for example, households, what's their way of living, how do they use the landscape. Satellite images, of course. Images are often from camera traps, spot often mammals, tracking data with collars, animal tracking. So there's actually quite a lot of people working with satellite images and sensors, apparently, measurements. That's good. Also some images, and probably also others like maybe sound, or but those are them, sensors. All right, very good. A lot of observation reports. Good, thank you. So what you see here is already that there's quite a lot of diversity in what type of data you're actually looking at. Sometimes it's your own, sometimes not. So sometimes you've got full control over how the data should be shaped, and sometimes you don't have that at all, because it's not your data, but you want to use it. And then the fiddling starts, how to get that data into the framework that you require. All right, thanks. So we move on. Last question, what tools are you using to work with your data, to make sure that the data that you are collecting and that you need to put into a structure that you can make your models and your algorithms or your reports, what kind of tools are you using? I can already, this is a Word cloud, I can already tell you from surveys that are regularly held that the spreadsheet, Excel, is actually one of the most used tools available. I'm quite interested in which tools you are regularly using. So let's say every week or every day, maybe even, to work with your data. Excel, indeed, yeah. QGIS, Power BI, Microsoft, Info, GIS, Accent. Yeah. If you look at ArcGIS, QGIS, Python, they require, of course, quite a lot of skill. Excel also, but it's easier, of course. Tableau, Power BI are reporting tools. Very good. All right, quite a lot of GIS people in the room also. Interesting. Last. We get some exotic names as well. Very good. Thank you. So now let's dive into the beginning of a little bit of inspiration. What can you do? So maturity levels of data-driven nature conservation. What are we talking about when we talk about this? Next slide, please. So first of all, the domain, it's nature conservation. And when we talk about nature conservation, we talk about landscapes, habitats, land cover, those types of things. We talk about all the species that are inhabitants of these landscapes. Could be mammals, that could be butterflies, that could be birds, that could be anything. And of course, people. And people could be there as custodians, they could be there as poachers, but people are always around. So if you look at those axes between the landscape and people, you often see projects where you engage with the community. When you look at species and people, it's often about human-wildlife coexistence and about poaching. And when you look at the species and the landscapes, the topics are often monitoring of biodiversity and also improving the habitats so that the species can easily move from one place to another, like corridor findings and so on. The icons in the middle, the pencil all the way to the globe and so on, I will explain on the next slide. That's actually the scope of the maturity levels. So I ordered them from 1 to 5. Mapping an area is everything about that you use to understand what's happening in the area. So it's literally mapping, creating maps. It's using satellite images, but also camera traps, sensors, anything that you use to record what's actually happening in the area. Monitoring is the process of looking for changes and to see if there's any trends, and to see through time how your measurements are actually evolving, and whether, for example, you can assess then whether the measurements that you took, your interventions that you planned and executed, whether they have any result. The periodic assessments are more related to, are there any risks that you should look at, that you should be aware of? And often you create those risks kind of periodically, maybe every month or every season or every year, and to see what are the biggest risks, and can I make some plans to avoid these risks, or to make the risks smaller, or to mitigate them. Then, of course, the third level is when you use the same data that you have been collecting all over to make predictions in real time, so that you understand how things are evolving right now. Of course, real-time predictions are more important for avoiding problems that occur right now. So the periodic assessment is more something like climate change. You want to know how the waters that are becoming warmer are affecting corals, for example. But real time, it's more like, is there now a poaching incident or fire incident, and how can I mitigate that at this particular moment? Also with human-wildlife conflicts, if there's a bear near town or in town, then you want to know what could be my next steps to reduce that risk. Scenario-based projections are future projections where you use information you got to manipulate and experiment with the future to see what kind of scenario would be the best scenario to follow to improve things that you are after. I will give a few examples for each. So the mapping, as I said, you can use the methods as you already explained also. You use satellite images, you use camera traps and other sensors, also field observations. And they are related, of course, to the different elements of this triangle. You look at landscapes, you look at species and at people, and all the relations among them. And that is what the mapping is all about. So the species, you could look at presence or absence. Are they simply there or not? If you know the species are there, what are the distributions? Can we create distribution models like Maxent that I saw around? It's often used for that. Can I maybe even make an estimate of how large my population is? Of course, that's not only technology, that's also a lot of methodology, because you need to set up your sensors and your calculation methods based on how you survey the area. Same is true for habitats. You can look at habitats at many different levels, and I will explain one or two examples also in this presentation and workshop how it can be done. And disturbances is more like the presence or absence of people that put snares in the fields, or are logging illegally or legally some areas, overfishing and so on, that you also need to know about. And data-driven organizing or fact-based management and so on are terms that relate to data that you collect. So data is central here. If you don't have the data, you talk about opinions, and we want proof that something happens. So that's how we try to see, can we, all those elements that we are after, can we somehow measure them? And if so, how can we measure them? And how can we translate what is being measured to people in the field so that they can take proactive action? So just a question, how are you currently using and mapping whatever there out in the field? I will show you a few examples of what we are using and supporting currently. The sky is the limit, but I'm interested in what kind of methods and tools are you currently using to record and map everything that is there to be found in your area of responsibility. mobile collectors, so it's handheld, for example, Android or on your iPhone applications, camera traps and cameras, audio recorders, okay. Lots of cameras. Just as many people collecting information in the field. Acoustics, okay, German. GPS collars. Interesting, okay. So I don't see a lot of satellite images here, not yet, or third-party data that you can also collect from the fields, maybe collected by citizen scientists, other projects, and so on. But this is quite regular of what you can find indeed. Thanks. Yeah. Transacts. Cool.
Okay.
So if you look at the tool suite that we provide through the SensorClues platform, and that has been enhanced quite dramatically through the Nature First program, then we also support, of course, the handheld data collection apps, which we call then CLUI Data Collector. But we also connect with OpsIdentify and other citizen science apps, which are often used by birders and other people that love nature and walk through nature. We work together with ADEX AI for camera trap images, but also with TrapTagger and some other known solution providers that work with CamTrap image recognition. Of course, it's important to upload all that kind of data, historic data, third-party data, map layers to the platform so that you can integrate it all. Sensor integrations are important. I did not see a lot of them, but you mentioned them before. There's also information from providers like the Global Forest Watch, which you can use to see if there's any logging taking place or any fires, which you get for free if you know how to get it and integrate it. There's also knowledge mapping, which is actually something that I will dive in a bit more, because we look at data, but we of course also look at how can you use the knowledge that's available about a certain phenomenon. Ecosystem-based maps and habitat maps is something that I will explain, and environmental time series analysis as well. But those are using remote sensing images, sometimes combined with ground truth, to create products that help you to analyze mostly, of course, the environment, the landscape. This list is growing, and every time there's a new project, an element could be added. Thanks. So when we look at the second level, then once you start collecting information, then if you do it through time, you can see if there's any changes in what you collected. So the definition of monitoring is tracking change in space over time, because we are looking at this is the definition that we use because we look at landscapes. So there's always a location, there's always a time. And if one of them is not there, if we don't have a lot long, if we don't have a timestamp, it's difficult to say anything about the state of the nature. But of course, then the questions become, what changes are you really looking at? And are all of them significant? And when would you like to be alerted about something that changes beyond a certain threshold? What metrics are you going to use, and how can you collect that information most efficiently, and how can you process all the other required information as well to make your analysis process efficient? So that's what we look at when we talk about monitoring. Then the simplest one is just looking at numbers. So you saw a number of animals, let's say elephant or the black and white rhinos, every month. And then here you can see that in July, you saw most of them. It could be because in July, the vegetation is less, so they are easier to spot, while maybe in January, February, the vegetation is high. So in that case, it might be very, very hard to spot those animals. So there's bias in the data. You have to be aware of that bias. In this case, it's the observability bias that could be in this data, but of course we need more content and more context to understand what these numbers actually mean. But this is a very often way of looking at monitoring in the field. Quite accessible and easy to produce. That being said, of course, when we talk about monitoring and using data sources, one of the things is that we often see that data collection is siloed. So, for example, in one nature conservancy, you could find biologists who are collecting information about elephants. But there's also community workers who actually also report elephants, but then in relation to human-wildlife conflicts. And then it's not always a given that those elephants also are included in the calculations of how many elephants did you actually see and where did you see them. So crossing domains between community workers, biologists, security rangers who are actually patrolling the area to avoid poaching and so on. Those data collections are often siloed. And one of our ambitions is, of course, is to break down those silos and make the information readily available. The same is true for information that is being collected on, for example, elephants by student projects. And then the students after 6 months go. And by biologists who do this as a profession in surveys every now and then, and so on. So also the way and the period in which data is being collected often results in silos that are quite difficult to bring together later. This is one of the problems that we cracked quite efficiently within the Nature First program. I will show you later. Another way of monitoring is, of course, looking at trends. So then you try to see all those sparks. Is there really a trend that we can discover? Is things slowly going up or down? Still not very hard, but it's easy if the software does it for you. Next one. The other one is looking at deviations. And here Michael Mitchell is actually involved here. Deviations, for example, when you look at vegetation index. Sorry, wat ben je aan het doen? Ik zit midden in een presentatie. Sorry, interruption. The vegetation index is one of the things that you can look at through the number of years. Here you see it from 2019 to 2024. And then when you look at the 2024, how does it deviate from the annuals, the years that were before? So you see here that the red pixels, actually the vegetation index degraded, it became drier, it became less green, and the greener areas regenerated. So they are becoming greener, more than average. So those are also ways of looking at changes in the landscape. Attaching, let's say, a kind of opinion about it to judge what this really means, of course, also really requires expert knowledge and discussions. So when you are monitoring in time, you are monitoring things in space through time, then what kind of methods are you using? And of course, you might be using lots of them. So here again, please rank the methods that you use. And just to have an impression of which ones you are already familiar with. So occurrence monitoring means you look at, is the species available or not? Is it present or not? Thresholds could be like an elephant is moving or not moving. So if he has a collar and the elephant is actually not moving for more than 12 hours, you might want to get an alert because maybe he died or maybe he's caught in a snare. Geofences is an animal or a car or something else moving in or outside an area. Algorithmic changes, surveys, like questionnaires, algorithmic change detection. All right, statistics, trends. So it's quite complete. That's very nice to see. Good. All right, thanks. So one of the things you can do with data, which is important to do with data, is to combine. It's quite logical, but here's an example of combining data from observations. What did you see? For example, here we were looking at the bear, and then where did you see the bear? And then the left upper picture is actually a hotspot map of where the bears have been sighted. But that actually could contain an observer bias, because maybe the observers only were in that area, and we were only paying attention in that area, and they did not scout the rest of the scene. So the lower picture, the bluish one, is the picture of which shows you the patrol density. So if you combine the observer, let's say, effort, so the efforts you put into observing and seeing and recording signs of presence and sightings of the bear, then you can create a likelihood map, as we call it, which is shown on the right-hand side. And that one reduces the observer bias quite dramatically. And it shows you way better than the hotspot map, where you could look for signs of presence of the bear, and also where you may not have been, where you also could be looking still to find more. So the yellowish areas that you see on the right hand, they are also on the edges of these polygons. And just outside these edges, it could be expected that you would find more. So in your next week patrol, this could be a nice place to look for signs of presence of the bear. If these maps were thematically focused on snares, then the same story, of course, would count for snares. So in the yellowish areas and outside these yellowish areas, you look for more snares, while in the dark areas, you may decide to not patrol that area for the next 4 or 5 weeks and go back there later. So we will not dive into that right now, but it's good to think about what kind of bias do you think is there in your data. So you've got the observer bias, you've got maybe a bias determined by the technology that you are using, a camera trap. If you place it in a certain angle, you will see all the mice and all the other small animals, but maybe not the elephant that passes by. The other way around, if you put it quite high, then all the small animals that pass under the camera won't be noted. And the same is true for insect catches like the Malaysian traps and those types of things. So you have a method that is optimized for something. The question is, can you also use it for other applications, which is an important question which we dive in later. Next slide. So likelihood maps is something that you also can use for combining and reasoning about it. And reasoning can be done automatically, but in this case, it's a visual inspection. So you see here the likelihood of human-wildlife conflicts with bear, and you see actually the above one is the presence of the bear, and the below one is the likelihood to find human-wildlife conflicts with a bear. And then if you see that those conflicts are located in a certain area, while the bear is also present in these other areas, you can start questions like, what are the good practices? What are the reasons why in these other areas there are no conflicts? While in that particular area that we are now focusing on, there are conflicts. So it helps you to focus. It's an important aspect, of course, of data to show you where are the gaps and where are the things that are interesting that you can learn from. The real-time predictions is something that we will have another webinar about, specifically dedicated in September. We have real-time radars, like you may have seen the crane radar on our website this last season. The cranes are migrating every year twice from the north to the south and back. But you can use those radars to predict the presence of animals in a certain location or even poachers. And you can also predict risks like human-wildlife conflicts. And we will have a few examples in the other presentation, which will follow in September. We have simple radars, which we call radius radars. It's a very simple combination of where did you see the species, what is its dispersal, and then use it to draw an area on the map, which you can see as a kind of search area. In that area, the animal could be present, and could be causing problems. So if you have fast response team, bring it into that area to avoid further problems. The likelihood radar shows you more predictive also towards the future, where the risks are higher. And we've got research radars, which are incorporating the latest and the greatest scientific insights, often involving PhD students and others from the academies, from the universities, to find out relations like how is an animal using and moving through the landscape. I will go into the next part. One of the things that you mentioned before is data modeling. And we actually use knowledge graphs to map and model our databases. So the premise here is that if you want to model the web of life, which you actually try to do, all the relations between all different types of species, abiotic and biotic factors, and all the relations between them, you need a technology that simulates that and that allows you to create a graph, a web. So if you look at we call that now currently data fabric. You may have heard about data lakes and about data warehouses. Data warehouse is often kind of SQL database, lots of relations and entities and properties that are modeled in a database like that. But they are very laborative, they are very expensive, and they are not very agile. So if your insights change, if you learn new things and you want to implement those into your system, then your data mart and your data warehouses are often failing that quite easily. And a data lake is the data lake is something that people use to put all the different data sources in one big lake. The problem with the data lake is that if you throw it into the lake, it might be hard to find it back. And the data fabric is actually the solution to that. And it uses a process that I will elaborate a bit more. But it allows you to integrate, for example, Natura 2000 sites database, which is on the internet, Korean land cover map, which you can find on the internet, the UNIS habitats and species list, and the IUCN species list, the red species list, and other knowledge resources, which you actually can find open source on the internet and can use to inform your database and structure your database in a very solid and scientifically proven way. So you don't invent the wheel, but use all those knowledge resources which are at your disposal. Next slide. So there is some technology there. You've got a raw data, and that has to be turned into a triple. A triple is actually two nodes and a relation in between those two nodes. So there is a bear and there's a salmon, and actually the bear is being eaten by the salmon. So those are two nodes with a relation in between that the bear actually likes the salmon. So there's some technical processing there. And this looks quite difficult, and it is. But we automated this in a very high extent. So for end users, this process is underwater and it doesn't affect you. It helps you to improve the quality and the accuracy of your data and also of your models, also of your AI models, because they can easily use all the data that is already out there. You can leverage the graph also to analyze complex relations and start asking questions and reason over your data. I will give one or two examples later. So here you see the data model in the pool party environment. It's like a normal database. You've got relations and properties. And here you can see that we've got a UNIS habitat classification, formerly published by UNIS. And we've got here also some tree species that are of interest for our area. And then you can see that the beech is actually is dominant species in a fagus woodland. And that is given, that is just mined from the internet, and you don't have to maintain all that because this is all given, and it only needs the modeling and the processes in place to harvest this knowledge. Then later, if you create a digital twin about bears, for example, and you know that the bear actually like beech nuts, then from here we know that beech nuts can be found in fagus forest, which is quite logical because those are forests with beech. Next one. So you got the taxonomy, which is very known, like you've got the birds and the mammal and other biological taxonomies. You can use it for everything. You've got the ontology, where you add relations and properties, which are more than just hierarchy. Next slide. And then you can actually start questions like, give me all the habitats in a certain region, and I want to order it in the importance of these habitats for the red species list. So if there's any red species list species, and those relations can be harvested from those graphs, which are publicly available. Same, you can ask question like, the bear in October, in autumn, likes a number of food resources. Where can I find those? In which habitats? So if these habitats are mapped, and you, for example, have land cover maps, then you can quite easily answer these questions through the graph. And that allows you to use knowledge which is actually mined and encoded by others in your models, and you don't have to hard code all those knowledge rules in your own models. So think about questions that you would like to answer with a knowledge graph. So it's data modeling. It's an advanced data model. Maybe it's the question I doubted a bit whether I should ask this question, but because it's a lot of new stuff maybe. But let's see what happens. So see the knowledge graph as an advanced way of data modeling, creating database schemes which are way more agile than the relational databases that are kind of mainstream, but becoming old days early. Of course, they will remain there forever. They are very powerful for certain purposes, but for mapping the web of life, they are not. So let's move on. This was a bit of a difficult question, so let's move to the use cases. We have weekly conservation innovation hub sessions in which we discuss a few things. It's a platform for collaboration, and where we also work together with scientists and others to make their research findings and their algorithms they developed available to NGOs and nature conservation areas, organizations in the field. And we do that by weekly asking, do you have a demo that can inspire others? Do you have short tech questions? Because you are probably not part of a larger team that can answer all these questions. So within these sessions, we have the different expertises available. And the last question is, would you like to discuss maybe an approach for a new idea and how to tackle that best? And then the next slide, I have a few use cases of projects that we have been working on. There's more, but there is one which is related to a daily report that has been created. There is about activity patterns, about land cover monitoring, environmental time series analysis, the setup of a central data repository, a human-wildlife conflict radar, and wildjets using GenAI to simulate a bear. So we have time for 1 or 2 examples. So please, in the chat, you can explicate, you can give your preference for one of these use cases. Would you like to learn more about the daily report and how that worked? Would you like to know a little bit more about the classification of ecosystems and landscapes, environmental time series analysis, or the setup of a warehouse, like the central depository?
The bear radar is Anna
Dangerfield
from Canada, if I recall well.
And one more bear, so we go for the bear. So the ambition actually was to predict in real time where human-wildlife conflicts with a bear can be predicted. The approach here is a project. In other, sometimes we work with volunteers, but here it was a project, a Nature First project. It has a duration of 3 years, but because we develop everything in such a way that it can be replicated the setup of the simpler version of this radar, the radius radar, is only 3 days. So we can get the radar up and running in just a few days in almost any area in the world. And of course, if you want to go all the way to the research radar, the sky is the limit. You can also work on it for 3, 4, 5 years. But the initial version here shows you where a bear was sighted, and actually a bear conflict was being recorded. And you see in the background a risk map, which is amplified where the bear actually was sighted and where this incident was recorded and how long ago. You see a red line around the bear, which indicates the area where the bear could be since the last observation. In September this year, there will be an exclusive and section about the bear radar in total. So this is what I will end here. Any other one?
There's a question in the chat. Can it be used in human-reptile conflict?
The radar actually is developed for bears, and we are working on a radar for elephants. To make it specific for reptiles, for example, well, if we look at for any other species, also wolves or other species, we start with a research project because we need to know all the characteristics of that species, how it is using the landscape, what features of the landscape are important for that species, and so on. So the principles indeed can be used also for any other species, even for non-related problems and non-species related problems like poaching or other illegal behavior in the field. But it requires to start with a research project of, let's say, a few months at least.
Okay, we have about 6 minutes left in this webinar, so I suggest we go to the final steps here.
All right, yeah. So you saw a few examples, 7, and I'm sorry we couldn't deal with too many of them. But if you have a project, next slide please, then the question always is the solution already out there? If so, often the cheapest and the most effective way is just buy it. But if there are no buying options, and in this field, it's often quite hard to buy something which fits your situation and is tailored to your situation, then the question is, can you make it yourself? And should you make it yourself? And because if you made it, can you also maintain it? As a researcher, it's not always important to maintain it. Developing the algorithm and the models and the insights is an objective on its own. But if you want your solution to be carried through and to be used in the field, then the question becomes, can we also co-create it? So our motto is always, let's join forces and see if we can together develop this. Because our strong belief is that together we can turn wild spaces into safe havens, but of course only if we work together. We don't have, as Sensiclues, we don't have the knowledge about elephants or bear and others. That's the ecologists and the biologists that have that knowledge. At the same time, we do have a lot of knowledge on automation processes and developing applications and so on. So together we can make that difference. Do you have any interesting projects in mind? Anyone on the table here? Anyone? Maybe from the slide that I just showed before with the use cases, is there any project that you could think of that that you think I'm working on something and that could use the help of a team? Anyone? You can open your mic and just like time series analysis or any project with maps or with satellites or with drones or with camera traps or with modeling, occupancy models, any other challenge you have.
Okay, there's a couple of people in the chat. Siddhartha Sharma says, I'm working on reptile and big cats in the northern part of India.
Okay.
And Jacob van der Ploeg says, is the bear radar easily adaptable to other species?
Okay, yeah. So the easy is always relative, but yes, there are the radar is being developed in a way that it is modular, and there's config files that you can use to provide a number of settings. But for new species, the first question is what kind of species are we looking at, and is it somehow can it be compared to the bear or the elephant? And if not, then we will look at the species and study it more closely with you to see which parts can be reproduced. But a number of things can be easily reproduced. So the whole pipeline of automating the application to a web app where people can interact, all the user interactions are already can be replicated. The way data is ingested and processed is already there. So you can really focus on the modeling, on the thing that you would like to include in your model, and it's to make it species specific. And you do not have to worry too much about all the other aspects of automation, security, data fiddling, the harmonization of the data, and so on.
Okay, we're getting to the top of the hour, Jan Kees, and people are already leaving. Siddhartha says, so this model will be of great use. So I think let's continue the discussion on that, and we can definitely connect and follow up. Jacob says, very promising, thanks. It would be great if we can get a little bit of feedback from the participants on what did you learn or like most about the webinar. We are having several more webinars coming up. In April, we actually have 3 webinars coming up. The next one is April 12th. And we also have our conference, Nature First conference, the end of June. We will share the slides and presentations and links to you. So you can find here the QR codes to the webinars and also to the final conference. And then if we could end with a little bit of your feedback, that would be much appreciated. And also feel free to ask any further questions you have. You can also open up the microphone, but I just want to respect time, and I understand people may have to leave. So if you have to leave, feel free to leave. If you want to stick around for some questions, then we're here to answer these questions and further collaborate.
Also, I see, if I pronounce it well, Siddhartha Sharma in the chat. Please reach out and we can reach out to you as well, hopefully. I don't know if you've got your email, but otherwise we'll reach out and see if we can help you with a reptile big cat issue, the research that you are conducting there. Would be interesting to see what the things are that you are studying, and the things which you would like to predict or to model, and see if our data science group can help you achieving your results more easily.
Yeah, there's Stefania asks, in case we have some ideas for applications in the future, can we reach out to you?
Absolutely.
Absolutely. The easiest is probably through our website. Let me just put the link in the chat, sensingclues.org, and we have a contact page there in case you would like to reach us directly.
Yeah.
And yeah, thank you, Rebecca. And it's hello with an E, I think, Jan Kees, at Sensing Clues, or is it hello?
Hello. It's hello. Both will arrive.
Okay.
Sure.
So either in Dutch or in English, you can say hello to us, or hello. Siddhartha, surely I will be connecting. Forward. And Anna says, I'm interested in learning more about the bear radar and if you've tried this method for polar bears. Ah.
Mhm. Mhm. Yeah, polar bears is of course a different ball game than the normal brown bear that we've got in Bulgaria, Romania, Spain. But it would be certainly interesting to look at that phenomenon as well and that species. Very different habitat, of course. Very different dynamics. Would be interesting to explore. We are doing the bear radar developments together with Wageningen University. I'm not sure if Anna is in the call. Anna is a PhD researcher and Koen de Koning, assistant professor on digital twins. So if you reach out to us to work on this, then they will also be invited and will be participating quite heavily probably in exploring opportunities to develop radars that are related to their research objectives as well.
Yeah, there's
very
another
interesting to see.
question from Abbas. What about rodents? How is it possible to predict an acceptable habitat modeling?
That is a difficult question. Predict and accept a habitat for which the rodents would like to be, right? So you would require information about what are the preferences and the needs of a rodent, and are the habitats providing those needs. Rodents is a big group. Some of them are living in the city, some of them are living in the forest. So we would have to become more specific in this case, absolutely. But if you are researching this, then please reach out and we can have a chat about this to see which groups of rodents you are really looking at and which kind of environments you are studying. Whether you see rodents as a plague in a city is very different, of course, if you see rodents as a food resource in the forest or any other perspective. So the idea is indeed that within the habitats, we model the requirements of what we call it an ecological knowledge model. And in the ecological knowledge model, we describe a number of things about the species. In this case, rodents, we would say what kind of food does it require, does it need, and what kind of seasonal needs does it have. And then we can see where can these food resources be found, in which kind of habitats, which species, other species like flora species, but also abiotic factors need to be present for this rodent to accompany and to cater for all his needs. So he has a needs of reproducing, for feeding, sleeping, and so on. And then can we map these somehow to habitats which are most suitable for the species to satisfy those needs? And those can all be mapped through the knowledge graph. Quite a lot of that is actually can be found in Globi. I don't know if you know the Globi open source, linked open data source. It's a global biodiversity interactions. If you search for it on the internet, you can find for many species what kind of interactions it has with its environment. What it eats, even who it is, if it has, for example, it can eat insects, but also flowers, and it can have parasites, and all those types of things are models. And it's an open source database where many different researchers are contributing to, and it has grown very, very big. Very useful resource.
Great. Are there any other questions? Any other things you would like to ask Jan Kees at the moment? Any other thoughts or any other feedback? Thank you for those who provided feedback.
All right.
Let me just maybe close off then with the next webinar is April 17th. Albin Ameti from GraphWise will dive deeper into the knowledge graph that Jan Kees also mentioned. 24th of April, we have media strategy in human-wildlife coexistence. And April 30th, we'll look more into these environmental time series, tracking change. And for those of you who are interested to learn about the whole program of Nature First and all the cool things we developed as part of that project, we have a conference 25th and 26th of June in the Netherlands. And through the QR code, you can join us and register if you would like to come and participate. We will share this recording and the slides with you after today. Probably early next week, you should receive that. Feel free to share it with anyone you think is interested in this. Yeah, Jacob asked, will you share the recording of this presentation with us? Yes, so we will do that. Yeah. And as I said, feel free to share it also in your network if you think of anyone who may be interested in this or a future webinar. You can also look at one of the QR codes here is links to the event page of the Nature First website. So you can see all the events, webinars that are coming up where we talk further about these topics. If there are no more questions, then I would like to thank Jan Kees very much for your very nice presentation. And there was also in the chat a lot of good feedback. People, I think, really enjoyed it. And also the participants, thank you very much for participating from all over Europe, including Canada, so and India. So we really had a very nice spread over the world. Thank you very much. Have a good
thank you
of your day, and hope to see you at a future event or get in touch with us through email or other means. Thank you very much.
Thanks a lot.
Bye.
See you next time. Bye-bye.
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 Bye bye.